G'day. The other day I did a video on basic mill accessories, and I was surprised how well that was received, and so I thought, oh, maybe I should do one for the lathe. The problem with the lathe, of course, is that it hasn't got much in the way of additional accessories. Most of the accessories you want will come with the lathe, but there are a couple of things. So this video is just some basic thoughts on lathes, tooling, all that sort of thing. This is my lathe. It's the fourth one that I've had. The first was an old lathe, not terribly capable. The second one was a 7x20 Taiwanese Daishin, sorry, and that wasn't too bad. Then there was this one, and then for a brief period I had a Myford ML10. There are some accessories which are pretty much standard for lathes, and if you buy new you'll probably be supplied with these accessories. If you buy second hand you may have to go hunting around to find them. But typically what you'll have is starting with the basics, a 3-jaw chuck, and the rule of thumb seems to be that a 3-jaw chuck is around about half the lathe swing. So in this particular case it's a 12-inch swing lathe, and that's the maximum size thing that could swing on it without running into the bed, and so the 3-jaw tends to be about half that. Next to the 3-jaw is the 4-jaw, and a 4-jaw chuck is the rule of thumb for that one seems to be it's the next size up. So this is a 6-inch chuck, and typically the next size up will be a 8-inch, and so that's what this is, an 8-inch 4-jaw. You should also have a faceplate. The faceplate will probably be something very close to the maximum size of the lathe can turn, and this one is 11 inches in diameter. Then there'll be a couple of steadies. This is a weird looking thing, but this is the official CVA travelling steady. Travelling steady's handy if you've got long slender items that can tend to whip around a bit. This sort of sits on the carriage and is engaged very close to where the tool is, and so helps stop that whip. The other thing you'll have, or hopefully have, is one of these, and this is what's called a fixed steady. This bolts to the bed of the lathe and enables you to support long things down, well, not necessarily down near their end, but typically down near their end, and so you have the one end in the in a chuck, and the other end is sitting here. You can do end operations, you can do bits in the middle, all that sort of thing. I've seen people lubricate these with grease. I've seen people lubricate them with oil. It doesn't seem to matter too much, provided you've got lubrication. Then along with the big hardware, there should be some smaller things. Typically you want a drill chuck on a taper to go into the tailstock, and you'll also probably get some form of adapter which will go in the headstock that you can then put a centre in. So when you turn between centres, you've got something there that will take the bore of the spindle, which has generally got a taper on it, and bring it down to something a bit more usable. In terms of other chucks or other work holding devices, there are things like this. This is an aftermarket chuck, and some of you have seen this. I did a bit of a review and comparison on this one just recently. A collet chuck is a nice thing to have because it means that things are gripped a little bit more concentrically than you can get with a 3-jaw chuck, and so useful for having for typically this will go up to 1.5 inches, but smaller diameter bar stock, but also things where you might want to turn a bit, move it out, turn a bit more, all that sort of thing. This one's a commercial one. This one is one I made myself. This is an ER40 sized collet. Not difficult. Make up a fitting that fits onto the spindle nose, and then I think that's an M50 thread. That's an 8-degree taper. I bought the nut. they're not difficult to make. So, you know, if you're thinking, I'd love to have a collet chuck, I would suggest having a go at making one yourself. The fitting for my spindle here is what's called a camlock fitting. This is a D13. They go up to D18, I think, commonly. And the easiest way to tell what you've got is the diameter of the pins. The pins get bigger as the chucks go up, and there are tables out there which would tell you what those are. But this is a very nice way of retaining a chuck. There's a taper there which matches a taper on the spindle nose, and then it's locked in with cams that grab hold of these pins, hence the name camlock. If you've got a screwed chuck, it's not the end of the world. However, with something like a camlock chuck or something that positively engages like that, you can run the chuck backwards, which sometimes comes in handy. With a screwed chuck, you've got to be very careful, because if you run it backwards, it's in the direction of unscrewing, and so you might find that when you stop the lathe, the chuck might want to keep on going, unscrews, pops off. So, you know, if you have a choice between a screw-on spindle and something like a camlock, I'd be taking the camlock. To change chucks, you probably want to make up something like this. This is just a bit of plywood with a couple of strips on it, and it's sized so that it'll just sit across the ways like that, so that if this was a screw-on chuck and I was unscrewing it, if it dropped, it'd hit the timber and not the ways. As lathes get bigger, the chucks get heavier, and so for a small lathe, say a Myfield or a 9-inch Hercus style lathe, you can probably carry it in one hand, but as it gets bigger, it gets nastier. And so I have also seen people make up basically wooden V-blocks that'll sit under the chuck, so that when they're unscrewed or they're popped off, there's something there to support them. One of the first improvements I'd suggest for any lathe is fitting a quick change tool post. This one's an Aloris tool post. You can buy this style of tool post from all over the place. This is just the originator of this sort of tool post. There are also a European thing called a multi-fix, which is it's basically a splined drum, and you can move the tool round in, I think it's about 15-degree increments. Yes, useful. I'm sure people who have them think they're wonderful. I don't see the need myself, so I've never really bothered with it. These things, well, there are two styles of this too. This is a wedge type, and so what happens is when I pull that handle round, the wedge comes out and it jams itself into the dovetail on the tool, or on the tool holder. There's also another style which has got a piston that comes out, so that slides on, and then when you pull the handle around, a piston comes out and pushes on the tool. All sorts of arguments about which one is more accurate. On paper, the wedge style is a little bit better, but I think in terms for most hobby machinists, it's not really going to matter. One thing that I have got with my tools is, this one is my 45-degree chamfer tool, and I use that when I want to put a 45-degree chamfer on the end of something, obviously. But the big thing about this is that it's, as the name suggests, it's a quick change tool post. Right? To put a tool on is basically doing that. It's ready. Okay, so I have seen some people modify these. They put a lever handle or something up the top so they can swivel the post round. I can't really see much point. If you want a special angle, grind a special angle on a bit of high-speed steel, and you're done. I've also got something like that, so that when I want to centre something up in a 4-jaw, it's just a matter of putting that in, and that'll allow me to put a dial gauge on there. It's a useful thing to have, but there are occasions when a dial gauge on a magnetic base is useful. So don't just sort of say that's all I need. This is where I store my lathe tools. These are just a piece of aluminium angle screwed onto a board, and then the quick change tools sit on there. One of the first modifications I do these days is extend the chuck key. Originally this chuck key had the bar going through here, and the reason for doing that is that particularly with something like a faceplate on here, the standard chuck key is too short to reach in to get to the cam lock. And so I do this as a matter of course. I find it's very handy to get in there. And the other advantage is that you can then use this as a bit of a chip brake and use that to pull away chips. Never touch the chips with your hands because those things can cut. In terms of tooling for your lathe, what do you need? Well, I guess to start with, some people advocate carbide tooling, other people say high-speed steel. I use a mixture of both. I think if I had a smaller lathe, I'd probably be using mainly high-speed steel, just because to use a commercial carbide tip like this requires some horsepower and requires some rigidity. This lathe's got that because it's an ex-industrial lathe, but if you're running an imported mini lathe, I'd strongly suggest at least starting out with high-speed steel. So in terms of basic tooling, you need a tool to turn the outside, and this one cuts to the left. I use carbide because for the things I cut, cast iron and stainless steel, that sort of thing, it lasts longer, but you could use high-speed steel. I've actually got several boring bars. This one is a diameter 16, and so that needs a 16mm hole to start with. If you're doing smaller holes that you want to bore out, then there are smaller boring bars available. You need to consult catalogues and things like that. You can also do the same thing with high-speed steel. You may have seen the boring bar I've got for cutting internal threads, and that's a steel boring bar with a high-speed steel tip to it. You'll need some form of parting off device. So that's, once again, that's a carbide type parting off device, but you can get high-speed steel. I'll typically use this for brass and small things like that, and this one here I use for steel and all those sorts of stainless, those sorts of nasty things. The other thing that I've got here is some high-speed steel. This one's been ground for a 60-degree thread. I will typically have high-speed steel in some of these tool holders to put on radii, thread profiles, anything like that where you can't get a carbide tool tip to do it. Some people talk about using carbide inserts for cutting threads. I've never done it myself. I find that something like this is quite good enough. There are a couple of accessories that you might want to think about buying for your lathe. One of them is one of these. This is an Aloris knurling tool. You can make these if you want to. Nothing saying you can't. And I basically bought this. It was a box of bits that I got, and with the tool post, I bought the tool post second hand. And so I thought, right, that'll do. It's what's called a scissor style knurler, and that is the wheels come in from both sides, and that stops putting strain on your headstock bearings. For a lathe this size, that probably doesn't matter too much, but for smaller lathes, your mini lathes, that sort of thing, that could be a significant thing. So that just slides on as per the usual quick change tool post stuff, and then wind that in and out. The other thing that you might be interested in, particularly if you want to do round handles and things, is something like this. This is a ball turning device. It's incomplete because there's a handle that goes on here that I use to swivel that. There are various styles of this. This is sort of an up and over one, for want of a better term. Notice too, I've got here a homemade dovetail that sits on that tool post. And so that's one of the nice things about the Aloris style tool posts, is that you can make up things like this and put them on there. You've got to be reasonably precise with the dovetail, but it does work. The way this works, handle goes on the back, and that just swivels that in and out. You do need to line that up with the axis of your work, but that'll give you quite a serviceable ball for a handle if you're going to make a quorn or something like that. I've run through what comes with a lathe, things you might want to think about with a lathe, all good stuff. Now, the question that some people ask is, should I buy second hand, should I buy new? I'm in two minds about that one. if you're a handy person who likes taking things apart and seeing how things go, then I'd say second-hands should be no problem. However, you buy a second-hand lathe, it's probably going to have some wear on it. It may not be complete. It may have a few problems with it. So it's a 6 of one, half dozen the other. Having said that, some of the smaller imported lathes, you hear all sorts of horror stories about the bearings being pretty crappy, or there's sand in the gearbox, or they're not properly lubricated, or all that sort of stuff. So it's maybe not such a terrible idea, even if you do buy a new lathe, particularly the small one, that you take it apart and just give it a once over anyway. I've got some things that I usually do for second-hand machinery I buy, not just lathes, but I did it for the mill and the grinder, all that sort of thing. And so there are some things that I'll just do, right? One of them is replace the V-belts. Typically they have a V-belt drive on them. I'll replace the V-belts for two reasons. One is that if it's second-hand, it's probably getting a bit old anyway. Those things rely on a bit of flexibility, so if it's got flat spots in it or anything like that, or cracks, it's not going to work as well. If it's a new lathe, without wishing to be impolite about this, they're usually built to a price, and so you won't necessarily get the best quality belts, and so you might be better off going to a belt shop and buying an Opti belt or a Gates or something or other, a V-belt of known parentage. If it's got multiple belts, you'll need to get a matched set of belts, and that's just a term that means the belts are all the same length, so you don't have one belt doing the majority of the work and the others just sort of sitting there having a holiday. But certainly V-belts aren't expensive, so I'd look at replacing those. My lathe's got flat belts on it. They're a bit more expensive, but same thing applies. I replaced those when I got it because they were in pretty poor condition. The other thing I'd look at is bearings. Now, typically the headstock of a lathe has got some pretty sophisticated bearings in it, so you're not necessarily going to be able to change those, but certainly on the smaller lathes, the bearings aren't specific, funny shaped lathe bearings. So you could consider changing them, and if there are other bearings for gearboxes, for motors, for that sort of thing, it might be worthwhile having a look at those and seeing whether they need to be changed as well. A typical roller bearing isn't going to cost much, but if it means that you're getting a decent quality bearing, an SKF or a FAG or an NTN or something like that, as opposed to a no-name bearing, then that's probably not such a terrible idea. The other thing with a second-hand lathe is the wiring. When I got this lathe, the wiring had been half ripped out, and so I had to work out what was there. Fortunately, I had a manual with a wiring diagram in it, schematic. But if you're an electrically knowledgeable person, you can probably do that yourself, but if not, you may need to get an electrician to have a look for you. And some electricians who do domestic work won't touch machines, so you might have to look around for an industrial electrician. But it's worthwhile checking that out, and even if you can't, with the power off, you just have a look around the place for loose wires, for wires that look like they've been burnt, where the insulation is fraying and all that sort of thing. You don't want to electrocute yourself. The last thing to think about is lighting. Years and years ago, the rule was you didn't have fluorescent lights over a lathe bed, because with the rotating chuck, if you got the wrong rotational speed, you'd get a strobe effect from the lights. The choices are you either have something like what used to be an incandescent bulb, but could be an LED bulb these days, that fixes onto the carriage and goes up and down, always staying in the same position relative to the cross slide, or you do as I've done. I've got some LED strip lighting over the top of my lathe, and so I've got uniform lighting right the way down the bed. It's a personal choice. You do want to try and get your lighting to be low voltage rather than 240 volt or whatever the mains voltage is. So LEDs are great for that. You could put an array of spots down the bed. Your choice, but you do need good lighting so you can see what you're doing, both in terms of when you're stopping and measuring and checking something, you want to be able to read that, but also so you can see what the work is doing there. Anyway, these are just a few sort of tips and thoughts that I've had on lathes, so hopefully this is informative, and we'll see you for the next one.